What's your most important job as an oil heat technician? You may think it's a 3 a.m. call that restores heat to a shivering family. But as critical as that job is, your top priority is ensuring that your customers' heating systems are operating at peak efficiency, reliability, and safety. And that job is accomplished through the preventive maintenance tune-up. A properly tuned unit will save your customer money and avoid the inconvenience and aggravation of a no-heat situation. Every time you perform a tune-up correctly, you're helping oil heat retain its preeminent position as a clean, efficient energy source. Doing it right today, one satisfied customer at a time, means a lot for our industry's future. Before we start to work, let's review the important do's and don'ts of customer care. Keep your service vehicle and yourself neat and clean. Wipe your feet thoroughly and wear protective booties when you're in the living areas. Don't leave fingerprints or smudges on customers' walls or woodwork. Whenever possible, enter and exit using secondary entryways. And most important, listen carefully to what the customer has to say about the operation of their system. In this video, we're going to illustrate the recommended sequence, tools, and techniques for performing a preventive maintenance tune-up. We understand that requirements may vary from company to company and require some modification to what's about to be presented. But the two key concepts that can never vary are cleanliness and efficiency. That applies to your work as well as to the operation of your customer's heating system. Now, let's get started. Courteously interview the customer to see if they've experienced any problems with the system or if they have any questions. Listen carefully and address any concerns the customer may have. Check the thermostat before proceeding to the heating unit. Check its location, make sure it's level, and note the heat anticipator setting. Leave the thermostat calling for heat at this time. Listen to hear the burner and/or circulator, and then operate the emergency switch to ensure that it's working properly. Turn the service switch off. Visually inspect the unit and make sure you spread sheets of newspaper or clean drop cloths to protect the work area. Verify the heat anticipator setting marked on the control and that controls are correctly set with the proper differential. Note what kind of filter and pump are installed so you can bring the proper replacement element, strainer, and gaskets. Visually inspect the flue pipe to be sure that it's properly screwed together and supported. If it isn't, add that to your list of things to do. If the burner has not been in operation for some time, it's important to perform a quick fire test to ensure that the heat exchanger surfaces are thoroughly dry. Run the unit for at least 5 minutes. Perform a smoke test and ensure that the unit is functioning properly. Note any problems so that you can repair them during the tune-up. Check the draft drop by testing at the breech and over the fire. If the drop is greater than 0.04 inches, there's probably a buildup of soot and scale, or you may have air leaks in the unit. At this point, let's stop to consider that there are thousands of different types of oil heat equipment operating in our customers' homes. Once in a while, you may come across something you've never seen before. When that happens, there are 3 rules that you must follow. Don't panic and don't badmouth the system. If it's been working for many years, the customer probably has more faith in it than they have in your opinion. Look and think before you rip and tear. Never disassemble anything unless you have replacement parts or gaskets, and treat the old stuff carefully. If you come across an unfamiliar system in the field, do the quick fire test and contact your supervisor for further instructions. But don't talk to your supervisor within earshot of the customer. If the unit is an antique, you have the opportunity to sell the advantages of a modern, high-efficiency oil heat system. Of course, it's much easier to sell your customer new equipment if you haven't just broken their old equipment. Now, let's get back to our tune-up. Inspect the oil tank for visible leaks and note the level on the gauge. Check the fill and vent pipes. Make sure that the caps are in good shape, fit properly, and are not obstructed. Check the condition of the pipes. Rotted pipes can allow water to enter the tank. If the tank is buried, measure the oil level with your measuring stick and use water-finding paste to make sure there's no water. Remember, always check for water in a two-pipe system with the unit shut off. When you've completed your outside inspection, gather your vacuum cleaner, brushes, additional tools, a garbage bag, and replacement parts from your truck. Shut off the oil valve and remove the filter canister using a pan to keep any oil from spilling. Inspect the cartridge and filter can for evidence of excessive sludge or water. Remember, this is a preventive maintenance call. If you find a problem, either fix it or notify your supervisor so corrective action can be scheduled. Clean and check the filter can and replace the cartridge and gaskets. Inspect the oil line for kinks or dents. Check to be sure there are no compression fittings. If you find any, replace them with flare fittings. Clean or replace the pump strainer, carefully scraping off the old gasket before installing a new one. Open the valve, turn on the switch, and bleed the unit. Run oil through a clear tube into a container until there are no visible air bubbles. Check for leaks at the valve stem, filter, and the pump gasket. Install your vacuum gauge in the T at the pump and your pressure gauge at the end of the nozzle line. On a lift system, the rule of thumb is that there should be 1 inch of vacuum for each foot of lift, 1 inch for every 10 feet of run, 1 inch for the filter, and 2 to 4 inches for the OSV valve. Operate the unit and increase the pressure 40 to 50 psi above the recommended setting, not exceeding 200 psi. Check that the pressure reading changes smoothly as you turn the adjustment screw. A pulsating or bouncing needle could indicate a leaking oil line or a bad pump. After adjusting the pump back to its proper setting, wait until the unit shuts off on safety and verify the safety timing. When the unit shuts off, the pump pressure should drop no more than 15 to 20% and then hold steady. If the pressure continues to drop, the pump has a bad cutoff and requires replacement. At shutoff, the vacuum should drop slightly and hold. If it drops to zero, there is a problem with the pump, the OSV valve, or the oil line. Mark the position of the firing assembly on the burner housing, remove the nozzle assembly, and note the nozzle type, size, and spray angle, verifying that these match the unit data plate or the listing in your manufacturer's OEM guide. Remove the nozzle and carefully drain the oil into a container. Inspect the nozzle adapter, replace it if it's stripped, cracked, or if the seat is worn. Install a new nozzle, handling it carefully so you don't damage the orifice or contaminate the strainer. Clean and inspect the electrodes and the porcelains. Check the ends of the electrodes for deterioration and the porcelains for chips or cracks. Adjust the electrodes to manufacturer's specs using the appropriate gauge. Clean and inspect the air tube along with the end cone slots and holes. Check the end cone or flame ring to be sure it isn't warped, burned out, or covered with carbon. Be sure the combustion head doesn't extend into the chamber. It should be recessed. Reinsert the nozzle assembly into the air tube and secure it in place, making sure it's in the same position that you marked earlier. Remove the burner motor and check the burner housing for oil, which could indicate a loose fitting, cracked flare, or leaking fuel pump seal. If there are oiling points on the motor, lubricate each with 3 to 4 drops of SAE 20 non-detergent oil. Cooling slots should be clear. Check the motor shaft for end play. If it's excessive, replace the motor. Inspect the burner coupling to be sure it isn't worn or stripped. Clean the air inlets and fan using a small brush. After you reinstall the motor, spin the fan a few times to make sure that the motor, fan, and pump are moving freely and that everything is properly connected. Check all wires and connections at the burner. Clean and check the transformer bushings and springs. Inspect the ignition wires. Clean the CAD cell eye and check the wires. Make sure the bracket is firmly secured in place and positioned correctly for good flame sighting. As you close the transformer, ensure that the bus bars are making solid contact with the transformer springs. When you plug in your vacuum or any power tools, be careful not to unplug any appliances. If anything has to be unplugged, attach your truck keys to the cord to remind yourself to plug it back in before leaving. If you performed a quick-fire test or if the burner was operating when you arrived, be extremely careful when vacuuming the unit. Don't allow any hot embers to get sucked into your vacuum cleaner, as they may ignite the filter and cause soot damage in the house. Remove the flue pipe and brush it out. Inspect the pipe's condition and replace it if necessary. Check the draft regulator to be sure it swings freely. If the unit has a stack relay, inspect and clean the helix and the relay contacts. Clean out the chimney base and check the chimney for blockages. If there's an accumulation of broken brick or liner, you should advise the customer to have the chimney inspected by a chimney professional and note this info on your service ticket. If the unit is equipped for power venting, clean and check the fan blower wheel, oil the motor, and check the draft proving switch. Remember to check and clean the outside hood and exterior mechanism. Scrub the flue passes, keeping your vacuum hose close to the brush to avoid spreading soot. If this were a steel boiler, you would first have to remove the baffles, then brush the tubes. Make sure to look for any signs of air or water leaks. Use a soot snorkel to clean the combustion area, being very careful not to damage the chamber or target wall. Inspect the condition of the refractory material and repair or replace it as necessary. Reassemble the unit using furnace cement if necessary to seal any air leaks. Double check to be sure the flue pipe is connected with sheet metal screws and supported. Proper fastening, sealing, and supporting of flue pipes is critical. With a CAD cell relay, the unit will continue to run with the flue disconnected. Be sure that cannot happen. Start the burner. Check the appearance of the flame and make sure that there's no impingement. Check the flame and combustion area with your flame mirror. Cycle the burner to ensure prompt ignition, smooth operation, and clean cutoff. Disconnect the thermostat leads and install a jumper across the TT terminals to keep the burner running. Check the operation of the high limit. Perform a smoke test, making slight air adjustments until the test produces just a trace on the test paper, or as specified by the manufacturer. Perform a complete efficiency test and record the readings. The steady-state combustion efficiency should be close to the following. Unless the unit is designed for positive pressure, draft over fire should be approximately negative 0.02 inches. Higher draft would lower the efficiency. Lower draft could indicate an improperly adjusted draft regulator, chimney trouble, or an overfired unit. The CO2 reading indicates the amount of excess air introduced into the combustion process. A CO2 reading of 10.5 to 12% would normally be acceptable. Readings below 9% or above 13% indicate the potential of generating smoke and soot. Net stack temperature is an indicator of how well the heat exchanger is absorbing the heat produced by the fire. Under 350 degrees net, flue gases will condense, causing pipe and chimney corrosion. As a general rule, as long as net stack temperature is over 350 degrees Fahrenheit, the lower the temperature, the higher the efficiency. The following steps will vary depending on the type of heating system you're working on. To test them, you should first remove your jumper from the TT terminals and replace the thermostat wiring. If there is more than one thermostat, make sure each is set 10 degrees above room temperature. Check the circulators and/or zone valves to be sure each operates properly. If applicable, lubricate the circulator motor and bearing assembly. Check the circulator couplings and motor mounts. Check the control settings to be sure they'll provide for proper heating, hot water, and circulator operation. Check the system pressure and the expansion tank. If there's an indirect water heater, check the circulator and control. Open the blower compartment to check the blower and lubricate it if applicable. Check the air filters and replace them from the customer's supply. Note the filter size on your service ticket and remind the customer to check and replace the filter regularly. Check the condition and tension of the fan belt and replace or adjust as required. Check the blower mountings and bearings for excessive wear. Then properly reinstall the blower compartment door. Finally, check the settings where the blower cycles on and off. If there is a humidifier, check it for proper operation, water leaks, and mineral buildup. Check the low water cutoff by blowing it down and draining water from the system until the burner shuts off. Check the automatic water feeder. Check the sight glass and replace it and the washers if necessary. If the glass fills with dirty, oily water, skim the boiler until it clears up. Check the main vents. Look for evidence of water leaks. Once you're satisfied that everything is working properly, double-check to be sure that you removed any jumpers you may have used, gather your tools, and check the area one last time. Pay particular attention to oil odors and to potential sources of oil leaks, such as the filter canister, pump, burner housing, and oil valve stem. Don't just wipe spills up. Use an absorbent and deodorizer. Always leave the area cleaner than you found it. Spend a few moments cleaning up. Wipe and clean all of the external surfaces of the burner, boiler, or furnace and work area. Use only clean rags so you don't leave behind the smell of oil. Use a garbage bag to remove the old parts, newspaper, or drop cloths so that nothing can fall out on your way back to your service vehicle. You should even take away any old parts that may have been left there by previous technicians, unless the owner wants to keep them. Be sure to check. Verify that the high limit control is operating correctly and all controls have been returned to their proper settings. Ask the customer to reset all thermostats to their normal settings and make certain the system is working properly. Fill out the service card completely so that on future visits the technician knows exactly what you've done. Include the work you've performed, the parts you've replaced, the efficiency readings, the nozzle size, and the safety timing. Fill out your company's required paperwork completely, including all of the information on the service card, plus the oil level and anything that needs to be followed up on. Before you leave, explain what you've done and assure the customer that everything's in good working order. Be sure to follow up on any concerns discussed during the initial interview. Explain the efficiency test results and what they mean. Have the customer sign the work order and give them the appropriate copy. If follow-up work is required, explain what needs to be done and why. Call your office to initiate a quote and to schedule an appointment. If your customer is not at home, notify your office so the customer can be called within 24 hours with a description and cost of the work. Thank your customer for their business. The preventive maintenance tune-up. You've just seen how it's supposed to be done. I hope you'll think about that in comparison to how you currently perform a tune-up. And I hope you'll remember the two key words, cleanliness and efficiency. But here's another key concept to consider. Keeping old, inefficient dinosaur equipment limping along might be saving your customer a couple of bucks in the short run, and it might make you look like a hero. But when it comes time for a new boiler, furnace, or burner, you're the technical professional the customer trusts, and it's your responsibility to recommend the upgrade. Getting all of your customers up to speed with today's clear burn technology is the real future of oil heat.